All right, finishing up the problems from earlier here, looking at number 5. So we want to find the x-coordinates of the relative min of f on this interval from -2 to 3. So relative min, we're looking at the derivative. We want to find out where is the derivative. A min is going to go from a negative slope to a positive slope. So we want to find out where are these values going to go from a negative slope to a positive slope. So we're going to look at this row in the table. So we're going from a negative to a positive. That happens right here when the x value is 1. That's the only time it's changing from a negative to a positive. So at x equals 1, justifying your answer, you want to say something like that. The derivative changes from negative to positive. So that's going to be your only point, your only x value. Part B. Excuse me. So explain why there must be a value c in this part here from -1 to 1 such that the second derivative of c is equal to 0. Okay, so we're finding a value between -1 and 1 such that the second derivative is equal to 0. So if we're going from first derivative to second derivative, this is like f prime of 1 minus f prime of -1 over 1 minus -1. This is going to be your f double prime of c. Okay, and basically f prime of 1, okay, f prime of 1 is 0, f prime of -1 is 0. So we get 0 minus 0 over 1 minus -1 is 2, but this is going to give us 0. Okay, and basically what we just did here, this is your average value, also known as mean value theorem. So that's your explanation, justification, whatever you want to call it there for part B. Part C, the function h is defined by this. Find h prime. Let's do that first before we start plugging in 3. So h prime of x, outside function, ln means we're going to have 1 over f of x times the derivative of the inside is f prime of x for 3. So we're going to have 1 over, what's f of 3? Well, come up here and look. F of 3 right here is 7. So that's 1 over 7 times, ooh, that was way off. Let's try that again. Times f prime of 3. So f prime of 3 is right here. That's 1/2. So this is going to give us 1 over 14. Okay, that's all we needed to show for that one. Again, taking your derivative, ln is 1 over the function times the derivative of the inside, just f prime of x. So there's your final answer, 1/14 is what we get there. Part D. Now we're looking at an integral. Okay, so we want to find the integral of this, and this kind of looks messy. All right, it does look like a mess, but this is the same thing as your u substitution. So really all this is, because we have the derivative, we have the function and its derivative inside there, you would set u equal to g prime of x and go through all of that when you, or I'm sorry, u equal to g of x. And then when you do your derivative, you end up with g prime of x dx and substitute that in, and you would have f prime of u and blah, 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 blah. But basically what you're going to end up with here is f of the inside function g of x evaluated from -2 to 3. Okay, but that's basically what this looks like. This is, I mean, this is going to get you your du, like I said, is equal to g prime of x dx. You would do your u substitution, work that all out, and this is what you would end up getting. So, and you could change your endpoints -2 and 3 because we have them here. You could do g of -2 and then g of 3 because both of those -1 and 1 are in your table. 1 and -1 for the values of f. So you could change your intervals from the integral and completely change everything. You could do that. That's a possibility. but it's not necessary. We don't need to do this. All right, so plug those in. So g of, I mean, that's what we're going to be doing right now anyway, so let's just plug those in there. So working from the inside out, see what we got. So plug in 3, so f of g of 3 minus f of g of 2. So g of 3, come up to your table. G of 3 is 1, so this is f of 1 minus f of g of 2. So here we are, g of, sorry, that should be a negative 2. Negative 2. So g of negative 2 is a negative 1. So then we go back to the table. F of 1. F of 1 is 2. Right here. F of 1 is 2. Minus f of negative 1 is 8. F of negative 1 is 8. So our final answer here should be negative 6. Alright, next problem. The first thing that we want to do is we have our slope field. We have this nice slope field here going from negative 3 to 3 in both the x and y directions, and we are asked to sketch a solution curve through the point 0, 1. So through the point 0, 1, let me change this to red so it stands out a little better. 0, 1 is right here. So we want to sketch the solution curve here. So basically what we want to do is just kind of follow what this curve would look like here if we were to have the actual graph here. So again, you're just kind of following what these lines look like here. Follow this down, follow these slopes. It's going to make a turn here and come back up like that. So that's kind of what your solution curve would look like there through that point 0, 1. The next one, we want to write an equation for the line tangent. Again, tangent line, that means derivative, to the point, or to the solution curve for part A, to the point 0, 1. Well, we already have the slope is dy dx right here, 3 minus y cos x. So the first thing that we want to do is just plug in our values here for 0 and 1. So to get our slope, we're going to plug in for dy dx those values. So 3 minus y is 1, cosine of x is 0. Again, be careful, cosine of 0 is not 0, that is 1. So this whole thing is equal to 2, because 3 minus 1 is 2, times cosine of 0 is 1. So that whole slope is 2. So we want to write the equation, okay, we want to write the equation of that line. So y minus y1 is 1 equals m is our slope, 2, x minus 0. And we basically just want to take and plug in this 0.2 for x. So y is equal to 2 times 0.2 plus 1, just taking this 1 right here, adding that over to the other side. So 0.4 plus 1 gives you 1.4 for your final answer there. And then the last one, again, I feel like every time we see these differentials, we get one of these questions where they say find the particular solution, and we just have one of these problems that has a lot of work involved. But again, it's nothing that we're not used to. We've seen a lot of these. So let's just jump right into it. So let me recopy here real quick, and then we'll get right into it. So we got 3 minus y cos x. Separate. Y's to the left, y's to the left, x is on the right. So 1 over 3 minus y dy equals cosine x dx. Alright, so we're going to start our integrating here. So this is the part where we do integrate. So left hand side, this is an ln, so we're going to have ln absolute value of 3 minus y. But what you do need to be cautious of is if we were to take the derivative of this, we would end up with the derivative of the inside would be a negative y. So we do need to have a negative sign out front there. So don't forget about that. Make sure you double check that for your final answer before you move on. And then on the right hand side, what gives us, when we take the derivative of it, gives us cosine, and that's just sine x, and we're going to put our plus c over here. Again, we're using that 0.01, so the 0.01, so x is 0, y is 1. So negative ln absolute value 3 minus 1 equals sine x is 0 plus c. This tells us that c is equal to negative ln of 2. Okay, negative ln of 2. Sine of 0 is just 0, so we're good there. All right, so now we're going to take that, we're going to plug it in right here, go through, solve this for y, and that will be our final answer. We're not trying to get any number, we just want the particular solution there, so basically just needed to solve this for y. So let's go through and plug that in here now. So let me switch this up. Negative ln absolute value 3 minus y equals sine x. C is negative ln of 2. So now I need to solve for y. I have to get this y here all by itself. Alright, so this is going to take a little bit of work. We have to get rid of the ln first, so I'm going to basically just take both of these sides and raise them to the power of e. Okay, so we need to think about how can we get rid of these absolute values, and if we look up above here, we know that our y values are going to be less than 3. Okay, our y value is 1 here, so since the y value is going to be less than 3, we can just get rid of that. So the first thing that I'm going to do is I'm going to multiply everything by negative 1. Again, you can do this in as many or as few steps as possible, but I'm just going to do this out here. I'm going to show every step so you guys can see what's happening here. Now I'm going to raise everything. I'm going to raise both sides. I'm going to take e to those powers, so e to this power here, to get rid of that ln, and e to this power here. So these will cancel. So I'm left with 3 minus y equals e to the ln of 2. And then also in that power is minus sine x. Okay. E to the ln of 2, that whole thing is just going to be a 2. So 3 minus y is equal to 2. But then we're also left with in this, because basically the way that can be split up is e to the ln of 2 times e to the negative sine x. If you remember your properties, your exponent properties from Algebra 1, you know, if these are being added together or subtracted or whatever, that can be split up that way, and e to the ln of 2 just gives you 2. Move the 3 over, so negative y equals 2e negative sine x minus 3, and then we're just going to multiply by negative 1 to get rid of that. So y equals negative 2e to the negative sine x plus 3, and that is your final answer there.